See Standard 12th Maths, Chapter 1, Applications of Matrices and Determinants, Exercise 1.6, Question number 2. Find the values of k for which the system of equations. Here they given the equations. The condition is the system has no solution and it has unique solution and infinitely many solution for different values of k. We are going to find the different values of k that satisfy these conditions. First, let me bring the given system and the augmented matrix form. I collect all the coefficients of x, y, z in the three equations and I write in the augmented form. Now, let us do the elementary transformation to bring in the row echelon form here. So, in that case, the first entry in the first row should be 1. But here I have k. So, look for the other entries in the same column. Both have 1, 1. See, but here in this case, I do the transformation with R1 and R3. R1 and R3. So, we interchange R1 and R3. R1 and R3 just to bring the k in the last row. So, the third row goes to as the first row and the second row just write as it is. Here the third row k minus 2, 1, 1. So, this becomes the third row here. And we do the other transformation here. Keep the first row as it is. And look at the second one. You have to make it as 0. So, compare it with the previous one, that is R2 is R2 minus R1. I subtract it from here. I want to make it as 0. So, 1 minus 1 is 0. Then R2 here, first one is minus 2k minus R1. This is minus 2, so becomes plus 2. Write R2 1 minus k. Then minus 2 minus 1. So, this becomes minus 3. Next, third row, first element here is k. I want to replace this as 0. So, you compare it with the R1. So, I multiply this by the same k, 1k. So, k minus k is 0. So, I multiply R1 by k and subtract it from R3. This is your R3. So, k minus k is 0. This is minus 2. If you multiply this by k, minus 2 minus 2k. Minus 2 and then minus k. So, this becomes plus. So, plus 2k. Then R3 here is 1 and minus k. Already this is k. So, k squared. 1 minus k squared. And R3 here is 1 and multiply R1 here k. So, 1 minus k. This is the second one. Again we are going to do the transformation, elementary transformation. So, in this case, in the row echelon form we got 1, 0, 0. In the third row, second element should be 0. So, in that case, you don't touch the first two rows. 1 minus 2 k 1, 0, minus 2k plus 2, 1 minus k minus 3. And look at here, minus 2 plus 2k. You have to compare it with the previous one. See, that is also with the same term. See, if you add, you will get 0. Minus 2k plus 2k 0, minus 2 plus 2 0. So, our R3 is R3 plus R2. R3 plus R2. So, 0 plus 0 0 and this is automatically 0. And the second one you will get it here. Here is 1 minus k squared. K squared plus 1 minus k. You just add. Otherwise, you can write it as here. Okay, just you write this as it is. And then here, minus 3, minus 3, 1 minus k. So, minus 3 plus 1 is here, minus 2 minus k. So, in the last row, the first two entries, we got it as 0. Now, see here, put the bar here. So, this is a matrix and this is a B matrix. That's all. So, now we have to find the value of k so that the given condition, first condition is no solution. The system has no solution. So, when you have the system has no solution, it is inconsistent. In the inconsistent case, rank of matrix AB is not equal to rank of A. So, these two must have the different rows. So, in that case, when do you get the not equal? So, one should be equal to 3, the other should be equal to 2. So, when it is 2 means here, rank of 3, for rank of A as 2 means this entry should be 0. So, when they become 0 here, just we'll do the small calculation. Here 1 minus k squared plus 2 minus k. Plus 1 minus k. So, minus of here, minus of k squared plus k minus 2. 1 plus 1 is 2. So, minus 2. Just you factorize here. 1 2s are 2 minus 2. So, 2 1s are 2. 2 minus 1. That is k minus 2 plus k. This is k plus 2 into k minus 1. So, you just factorize and keep this term here. The last term you will get here. Here you can cancel this 0. See this on the simplification I am getting minus k plus 2 and k minus 1. K plus 2 and k minus 1. So this term must be 0. When they become 0, I substitute, let me take k as 1. So k as 1 means you will get the whole term becomes 0. So when k is equal to 1, so rank of A you will get it as 2, and here if we keep 1 means you will get minus 3. So rank of AB you will get as 3. So rank of AB is not equal to rank of A. So in that case has no solution. No solution. Okay. Come to the next one. Next question is here unique solution. Second one, unique solution. Unique solution. See, when the system has unique solution in the consistent case. So, the unique solution is rank of AB is equal to rank of A. So, both should be is equal to 3 because 3 variables. So, both must be with the rank 3. So, the last row in the A matrix as well as in the AB matrix should not be equal to 0. See, already 2 entries 0. So, this should not be equal to 0 means the factorized term here, it should not be equal to minus 2. If it is minus 2, you will get 0. So, minus 2, and here k should not be equal to minus 2, and also k should not be equal to 1. If it is 1, you will get 0. I must not get 0. So k should not be equal to 1. Therefore, just you can write the factors, or you write just, already we found k should not be equal to minus 2 and k should not be equal to 1. So in that case, it will get the unique solution. So therefore, and also both are ranked with the 3. So the system has unique solution. Unique solution. Next case, third case. Third case is infinitely many solution. Infinitely many solution. So again here the system is consistent. So rank of AB is equal to rank of A, but it should be less than 3. It should be less than 3. Take 2, that is less than 3, the number of unknowns. Number of unknowns. So, in that case, here both the rank should be equal to 2. So, the last row completely it must get 0. So, when do they become 0? So, let me put here minus 2 here, k plus 2. When I put k equal to minus 2, I am getting 0. And also see right here k equal to minus 2, minus of minus 2 plus 2. So, minus 2 plus 2 is 0. So, the whole row becomes 0 for the value k is equal to minus 2. When k is equal to minus 2, the whole entry in the last row becomes 0. Therefore, rank of AB, rank of AB is equal to rank of A, and their rank is 2. So the system has infinitely many solution. System has infinitely many solution for k is equal to minus 2. So this is very important. Just you have to refer only this factors k plus 2 and k minus 1. So no solution. No solution case, just for k equal to 1, that only this entry is 0. So rank of A is not equal to rank of AB. And then unique solution. And then second case, infinitely many solution. Thank you.